When we talk about angles, angles have an initial side, which if we collapse our angle and then grow our angle, this is the initial side, and the side where we're growing is the terminal side. So here we see the initial side of our angle and the terminal side because we're moving in the positive angle. And positive angle is when we move counterclockwise. On the other hand, if our initial side is up here and then we rotate clockwise to our terminal side, that's a negative angle. So the idea of a radian is that if we have a circle of radius 1, then a radian, this length here is the same as this angle here. So that might be 1 radian, and this length right here is 1. And our whole circle, going all the way around, is 2 pi radians, and half of a circle is pi radians. So since we know that half of a circle is also 180 degrees, that means that pi radians equals 180 degrees. So to get from degrees to radians, we need to multiply by pi over 80. To get from radians to degrees, we multiply by 180 over pi. So let's try this. So let's convert from radians to degrees or degrees to radians. So if we want this to be in degrees, multiply by 1, and let's see what our rule said. Radians to degrees, number 2, multiply by 180 over pi. So we get 180 over pi degrees. 37 degrees, we need to multiply that by pi over 180 to get to radians. And we'll get 37 pi over 180 radians. Next, pi over 3, we want to multiply that by 180 over pi. So cross out our pi's, 180 divided by 3. Well, that is 60 degrees. And finally, 60 degrees, we multiply that by pi over 180 to get pi over 3 radians. Now let's have you try. Convert from radians to degrees or degrees to radians. So pause the video, and when you're ready, come back and check your work. So 1.5 radians, we want to multiply that by which one? We multiply by 180 over pi. So 180 times 1.5 is 270 over pi, and this is degrees. 50 degrees, multiply that by pi over 180, so that will give us 5 pi over 18, and that is radians. Now let's look at standard position. So we call an angle in standard position if the initial side of an angle is placed along the x-axis. So if this is x and y, then that means that the initial side is right here on the x-axis. The vertex is at the origin, and so our angle goes up here somewhere, or it could be over here, but that's in standard position. Coterminal angles have the same sides. So for example, this angle of 45 degrees has the same angle as if we went all the way around, and that's 360 degrees plus 45, so that is 405 degrees. And we can do that as well with radians. So if we had an angle at pi over 3, We can also go all the way around and back, so that's 2 pi plus pi over 3 radians to get the common denominator. So 2 pi times 3 over 3 plus pi over 3 gives us 6 pi over 3 plus pi over 3, which is 7 pi over 3. On the other hand, with both of these, we can go around clockwise. So going around clockwise, so we can also go around clockwise. So we start at our initial side and go to our terminal side. And remember, these are negative angles, and how far have we gone around? Well, the only chunk missing is pi over 3. So this is 2 pi, my whole circle, minus pi over 3. We need a common denominator, so we get 6 pi over 3 minus pi over 3, and that gives us 5 pi over 3, but again, remember this is negative. And similarly, up here, we can go around counterclockwise. Or we can go around clockwise. So going around clockwise, the only chunk missing is 45 degrees. A whole circle is 360, so if we subtract 45, and we get 315 degrees, and we need the negative because we're going clockwise. So let's find angles that are coterminal with 2 pi over 3. So we have a couple of choices. If this is our angle, we can go backwards. So if we go backwards, we go clockwise, we have 2 pi minus 2 pi over 3, which is 6 pi over 3 minus 2 pi over 3. So we get 4 pi over 3, but that's negative. So we're going clockwise. We can also have 2 pi plus 2 pi over 3. If we go around and back, that's 6 pi over 3 plus 2 pi over 3 to get 8 pi over 3. Alright, let's try another one. Now let's find angles that are coterminal with 125 degrees. So again, we could go clockwise. So 360 minus 125 is 235 degrees. We could go around once and then to the angle. So that would be 360 plus 125, which is 485. We could also go around twice and back, so then that would be 2 times 360 plus 125, and that would give us 845 degrees. Let's say we want to find an angle with measure between 0 and 360 degrees that is coterminal with an angle measuring 395 degrees. So since we're bigger than 360, that means that we have gone around and back to some angle. So we need to subtract off 360. So 395 minus 360 equals 35 degrees. Alright, next we have find an angle with measure between 0 and 2 pi radians that is coterminal with an angle measuring 3 radians. Well, what's 2 pi? Well, that's 2 times 3.14. So that's definitely already, 3 radians is already within our range. So this is just 3 radians. Let's say we want to find an angle, measure between 0 and 2 pi radians, that is coterminal with an angle in standard position measuring 25 pi over 4 radians. So, we know, let's see if 25 pi over 4 minus, we need a common denominator, we're going to subtract 2 pi, so 25 pi over 4, multiply top and bottom by 4, to get 8 pi over 4. So 25 minus 8 leaves us with 17 pi over 4. That's still bigger than 2 pi, so we subtract off another 8 pi over 4. That leaves us with 9 pi over 4. We're still bigger than 2 pi. Subtract off another, and we get pi over 4 radians is our angle between 0 and 2 pi radians that is coterminal with 25 pi over 4.